Hey everyone, and welcome to another Deep Dive.
Yeah, it's great to be here.
Today we're talking about sound.
Sound, huh?
Yeah, sound.
Well, everybody's heard of that.
Well, maybe everybody has heard it, but
Right.
do we really understand it?
That's a good point.
Like, what exactly is sound?
So sound, well, it's actually energy.
Energy.
Yeah, but it has to travel.
Okay,
It needs like a medium to go through.
like what?
Well, air is the most common.
So that's how we hear stuff, right?
Exactly. Like when you talk,
Uh-huh.
your vocal cords vibrate.
They do.
Oh, yeah, and those vibrations.
Okay.
They make the air particles around them vibrate too.
So it's kind of like a chain reaction.
You got it.
From like my voice to the air to your ear.
Precisely. That's how the energy travels.
But it's not the actual air particles flying into our ears, right?
No, it's the energy that's moving.
So it's more like
Think of it like waves in the ocean.
waves.
Yeah, the water itself doesn't really travel that far. But the wave carries energy across the surface.
So it's like doing the wave at a sports game.
Haha. I like that.
People stay put, but the wave goes all around the stadium.
A perfect example.
So these sound waves, what are they like?
Well, they have these peaks and valleys.
Peaks and valleys.
Yeah, we call them compressions and rarefactions.
Okay.
It's how the air pressure changes
Huh.
because of the vibrations.
And those travel outward.
Exactly, as a wave.
Fascinating.
And we actually call those longitudinal waves.
Longitudinal.
Yeah, because the particles are moving in the same direction the wave travels.
Oh, so it's like a straight line?
Kinda. It's different from those ripples on the water.
Yeah, those go up and down.
Right. That's a transverse wave, perpendicular motion.
So sound waves are longitudinal, got it.
Exactly. Now, these sound waves,
Yeah.
they have some special qualities. We call them properties.
Properties. Okay, like what?
Well, there's wavelength.
Wavelengths, huh?
Yeah, it's like the distance between two of those peaks.
The compressions.
Or two of the valleys, the rarefactions.
So a longer wavelength means.
A longer distance between those pressure changes.
Got it. What else?
Then there's frequency.
That sounds familiar.
Yeah, we talked about it a bit before.
With vibrations, right?
Exactly. It's the number of vibrations per second.
And what does that tell us about the sound?
Well, we hear it as pitch.
Pitch.
Yeah, a high frequency means a high-pitched sound.
So like a whistle.
Exactly.
Right.
Lots of vibrations per second.
Makes sense. Any other properties we should know about?
One more big one, amplitude.
Amplitude.
It's all about the intensity of those vibrations.
Fantastic.
Like how much energy they have.
And we hear that as.
Loudness. The bigger the amplitude, the louder the sound.
So a quiet whisper would have.
A small amplitude, not much energy.
But a loud shout.
Big amplitude, lots of energy being transferred.
Okay, I think I'm starting to get it.
It's pretty amazing, right?
Yeah, all this complexity in just a simple sound.
Oh, there's even more to it. But I guess we'll save that for later.
Before we move on, do you have any questions about these properties?
Well, I do have one.
Shoot.
You mentioned the speed of sound before. Is that related to these properties at all?
Oh, absolutely. It all ties together.
Tell me more.
Well, speed, frequency, and wavelength.
Okay.
They have this cool relationship.
Like what?
It's actually a simple formula.
Oh.
Speed equals wavelength times frequency.
So a longer wavelength.
Could mean a lower frequency if the speed stays the same.
Makes sense.
And the speed itself can change too.
Really?
Yeah, it depends on what the sound is traveling through.
The medium.
Exactly.
Yeah.
Sound travels faster in denser materials.
So like through water?
Or faster than through air. Yep.
And even faster through, say, steel.
Precisely. So the medium matters a lot.
Wow, that's amazing. So many factors at play.
It's all part of what makes sound so fascinating, right?
Absolutely. And we're just getting started.
I can't wait to dive deeper.
Me neither. Okay, so we've talked about how sound travels in waves, right?
Yeah, those longitudinal waves with compressions and rarefactions.
Right, exactly. Now, have you ever wondered what happens to those waves when they hit something?
Like a wall or something.
Exactly. Think about when you shout in a big empty room.
You get that echo, right?
Yeah, that's because the sound waves,
Oh, okay.
they hit the walls and bounce back.
Like a ball bouncing off a wall.
Exactly. It's called reflection.
So the sound waves are reflecting off the surface.
And the time it takes for that echo to come back.
Depends on how far the sound has to travel.
Exactly. That's why you get echoes in big spaces.
Like canyons or mountains. Yeah.
Big surfaces, lots of reflection.
Makes sense.
Yeah.
So this reflection thing is not just echoes, right?
No, it's way more than that.
Like what?
Well, think about musical instruments.
Yeah.
The shape of a guitar or a violin.
Yeah.
It's designed to reflect sound waves.
Really?
Yeah, in a specific way to create the sound we hear.
So it's like the instrument is controlling the reflection.
You got it.
Yeah.
And it's not just instruments.
What else?
Concert halls, theaters, those are designed too.
For sound reflection.
Yeah, to make sure the sound is good everywhere.
Wow. So much thought goes into this stuff.
It's all about using those reflections to our advantage.
Pretty amazing. Now, before we get too carried away with reflections, I have another question.
Go ahead.
We talked about how sound travels faster in denser materials, right?
Like water compared to air.
So what about something really dense like steel?
Ah, steel. Yeah, sound travels super fast through steel.
How fast are we talking?
Well, it depends, but way faster than in air or water.
So, like, you could hear a train coming from miles away.
If you put your ear to the track, yeah.
That's incredible.
It is. It's all about how those vibrations travel through different materials.
The denser, the faster.
Precisely.
Yeah.
And that leads us to another interesting point about sound.
What's that?
The range of sounds we can hear,
Okay.
it's actually limited.
You mean like we can't hear everything?
Right. There are sounds out there that are too high or too low for us.
Like what?
Well, on the high end, we have ultrasound.
Ultrasound, like what they use for babies.
Yeah. Those are sound waves with frequencies
Okay.
that are way higher than what we can hear.
So there's a whole world of sound we're missing.
Exactly. And lots of animals can hear those sounds.
Like dogs. Right. They hear those high-pitched whistles.
Yeah. And bats use ultrasound for echolocation.
Echolocation, what's that?
It's like they send out sound waves and use the echoes.
To see.
Kinda. It helps them navigate and find food.
Wow, that's amazing. So what about those low sounds we can't hear?
Those are called infrasound.
Infrasound.
Yeah, frequencies below what humans can detect.
And who uses infrasound?
Elephants. They communicate with it over long distances.
Wow, it's like secret conversations happening all around us.
It is a whole world of sound we're not even aware of.
So we got ultrasound on one end and infrasound on the other.
Yeah, and somewhere in between
Is what we can hear.
the human range of hearing.
But even that can change, right?
Absolutely. As we get older, our hearing can decline.
Especially for those high frequencies.
Exactly. It's a natural part of aging.
Before we move on, any burning questions about this sound spectrum?
I do have one question, actually.
What's that?
We've been talking about all these different sounds, but how do we actually hear them?
That is a good question.
What's going on inside our ears to make sense of those vibrations?
Well, that's a whole other can of worms.
I guess we'll have to save that for another time.
All right, but first, let's dive into some of the ways we use sound.
Oh, yeah. From music to medicine, sound plays a huge role in our lives.
Can't wait to explore that. All right, so music.
Ah, music.
It's everywhere, right?
Absolutely.
But, like, how does it actually work?
Well, at its core,
Yeah,
it's all about manipulating sound waves.
those vibrations we talked about.
Exactly. Creating melodies, rhythms, harmonies.
I get the melody part,
Mm-hmm.
but, like, harmonies, that's where I get lost.
Well, it's how different sounds work together.
How creative.
Creating chords, blending notes.
Still a bit fuzzy for me.
We can dive deeper into that another time.
Deal. But first,
Yeah.
let's stick with the basics.
Sounds good.
Like, how do different instruments actually make sound?
So each instrument, it has its own way of creating those vibrations.
Okay, so like a guitar.
Yeah, the strings vibrate.
Right, and that makes the sound.
But it's more than just the strings.
What else?
The body of the guitar.
Yeah.
It's hollow. It acts like a resonator.
A resonator, what's that?
It amplifies the sound, gives it that rich tone.
So the shape of the guitar matters.
Absolutely. It's designed that way for a reason.
Wow, that's pretty cool.
And it's not just guitars.
No.
Every instrument, it uses vibrations and resonance.
So like a flute,
Yeah, it's the air inside vibrating.
because you blow into it.
Right, and the shape of the flute.
Okay.
It determines the notes, the sound it produces.
So it's all about how those vibrations
Created and shaped.
to make the music we hear.
Exactly.
Now what about singing?
The human voice.
That's an instrument too, right?
It's the most amazing instrument.
But how does it work? No strings, no blowing air.
Well, we use our vocal cords.
Vocal cords.
Yeah, they're these folds of tissue.
Okay.
And when air passes through them,
Uh-huh.
they vibrate.
So that's how we make sound.
It's the starting point.
And then we shape the sound.
By changing the shape of our mouth and throat.
Like how we move our tongue.
Exactly. And our lips.
Make different sounds.
It's a complex process.
But we do it without even thinking.
Yeah, it's pretty amazing.
So we've covered music, but what about medicine?
Yes. Sound has a huge role there, too.
Like with ultrasound, right?
That's one big application.
You mentioned it before.
Yeah, using those high-frequency sound waves.
The ones we can't hear.
Exactly, to create images.
Of what's inside our bodies.
It's a safe and non-invasive way to see what's going on.
So like when you're pregnant.
Yeah, they use ultrasound to check on the baby.
That's how I saw my kids for the first time.
It's amazing technology.
And it's not just for babies, right?
No, ultrasound is used for all sorts of things.
Like what?
Well, they can use it to check your heart.
Really?
Yeah, to see how it's functioning.
And other organs too, I'm guessing.
Pretty much any organ that needs a visual checkup.
Wow, so it's like having X-ray vision.
But without the harmful radiation.
It's a huge plus.
It is. Ultrasound is a game changer in medicine.
Now, before we wrap this up,
Yeah.
there's this classic question.
Which one?
If a tree falls in the forest,
And no one is around to hear it.
does it make a sound?
The age-old debate.
What do you think?
Well, it's tricky, right?
Yeah.
Because sound, it has two sides to it.
Two sides.
Yeah, like the physical vibration
Yeah,
that's happening regardless.
So the tree falling, it's making those vibrations.
Whether someone's there or not.
But then there's the perception.
The hearing part.
Right, if no one is there to hear it.
Is it really a sound?
It's almost like it needs a listener to complete it.
It's a philosophical question.
Makes you think, doesn't it?
It does. It highlights how intertwined
Yeah.
the physical world and our perception are.
Deep stuff.
It is. And it makes you wonder
About what?
how much of our reality is shaped by how we perceive it.
Wow, that's a whole other deep dive we could do.
Maybe next time.
Deal. But for now,
Yeah.
I think we've covered a lot about sound
From how it's created to how we hear it.
and all the amazing things it can do.
It's truly fascinating stuff.
I have to say, I'm looking at sound in a whole new light now.
Or should I say, hearing it with new ears.
Exactly.
Thanks for joining us on this deep dive.
It's been a blast exploring the world of sound with you all.
Until next time, keep listening.